Welcome back. In today's video, we're looking at the prelim paper from 2019, right? And this is from the KZN province, right? So over here, they say that we have a triangle ABC, which is an equilateral triangle with sides D units long, right? So that's an important piece of information. Our triangle ABC is an equilateral triangle, right? That means that our triangle has equal sides, right? So all of these sides, AB, BC, and AC, are all D units long, right? And P and S are points on the sides, right? AB and AC respectively, right? So you can see P over there and S over there. And we have that Q and R are the points on BC, right? Such that this figure PQRS, right, this is a rectangle. That's another piece of information that's important, right? So PQRS is a rectangle, right? We also have that BQ is equals to RC, and they both equal to 2y units, right? And that's indicated to us in the diagram, right? We have two very easy questions over here. The first one, they want us to show that the area of the rectangle can be given by the following expression, right? And then secondly, they just want us to determine the maximum area in terms of the variable d. Okay, let's start off by populating our diagram, right, with the given information, right? The first thing they gave to us is that ABC is an equilateral triangle. So we can go in here and put in 60 degrees as our interior angles, because we know that for an equilateral triangle, the interior angles are all 60 degrees, right? We can also put in that the interior angles of this figure PQRS is 90 degrees, since this is a rectangle, right? The opposite sides of the rectangle are also equal, and the opposite sides are parallel as well. Okay, so now having done that, you should actually be noting the fact that now what you have done is created the Euclidean geometry theorem, right, which states that you have a line drawn parallel to one side of the triangle. Okay, you can see now that this line PS, okay, is now parallel to this side BC, okay, and because of that, we now have the situation of a line parallel to one side of the triangle, right? And that is the proportionality theorem, right? The triangle proportionality theorem. Okay. All right, so let's see. For question 11.1, right, finding the area of this triangle, of this rectangle PQRS, right, we know that the area of a rectangle, right, the area of the rectangle is given by its length times its width, right, so it's going to be given by PS, right, times SR, okay, but we can see that PS is equals to QR, so let's substitute that with QR, right, times SR. I'm going to write the reason here, since PS is equals to QR, opposite sides of rectangle. Okay, now it's very easy for us to calculate QR, right, because we know that the full distance BC is the same as AC, that's a distance of D, right? So QR is simply just D minus 2y, which is going to be D minus 4y. Okay, so QR is simply just D minus 4y Okay? Then we still need to multiply that by this length SR. Okay? And to find SR, you can see that you can work in triangle SRC. Okay? And in that triangle, right, SR is an opposite side. You have a given adjacent side RC. You have an angle of 60 degrees. So therefore, RC, right, times the tan of 60 degrees is equal to the wanted length of SR. Okay? So RC is given to you as 2y, right? We need that times the tan of 60 degrees. This is equals to the length SR. Okay? So therefore, since the tan of 60 degrees is the square root of 3, right, SR is simply equals to 2 times root 3 times y. So now working with the value of SR, there we can then now substitute it back to what we were initially calculating, which is the area of the rectangle PQRS, right? So now that is equals to D minus 4y times, right, this value of 2 root 3y. Okay. And you can see over here that that is the formula that they wanted you to show. Okay, you can just rearrange it to look exactly the way they've written it. So it's A, okay, is equals to 2 root 3y okay, times D minus 4y. Okay. And since in the next question they want us to find the maximum area of this rectangle, this becomes our optimization equation. Right, so for question 11.2, right, we are going to have to write this area equation in terms of only D. Right, so they want the area equation in terms of the variable D. Okay. So we are going to need a constraint equation. Right. So for our constraint equation, we are actually going to use the fact that I pointed out in the beginning, that now that we know that PQRS is a rectangle and PS is now parallel to the side BC, okay, we now have the triangle proportionality theorem, right? So we can take out some proportions from this triangle, right? So since we've already calculated the side SR, right, and SR is perpendicular to BC because of the interior angles of this rectangle, right, it's going to be very easy for us to calculate this length is C, right? And because we have this length is C, notice that it's going from one parallel line to the other parallel line. It's quite natural to then pair it up with BC, right? And then we need to find partners to work with, right? So our partners are going to be alongside, right? So it's going to be BC, right? Because we know what BC is, right? Against PS, okay? And we know what PS is. PS is equals to QR, and QR is equals to D minus 4y. Okay. So basically what I've done here is, you guys usually see it like this. Okay, you usually see it represented like this. I'm taking these proportions over here. Okay, so you usually see it drawn like that. Okay, so we're going to say, right, this is just to help us to develop our constraint equation, right? The length AC, right, over the length SC must be equals to BC by PS, right? And this is because we have a line, right, parallel to one side of triangle ABC. Okay, so then from there we are going to need this length SC. Okay, but to find the length SC is very simple. It is still within triangle SRC. Okay, so SC is just going to be the square root, right, of SR, okay, which we know is 2 root 3y squared, plus our C, which we know is 2y squared, and this is the theorem of Pythagoras. Okay, so SC simply works out to be the square root of, I'm going to write it out like this, 4 times 3 times y squared plus 4y squared. Okay, now you can see we have a common factor of 4. So SC is equals to the square root of 4, right, into 3y squared. Let's actually take out that y squared as well as a common factor, right? So 4y squared into 3 plus 1. Okay, so SC is going to be equals to, well, you can see that you now have the product of two things underneath the square root, right? So you have this A times square root B equals to square root of AB, right? So that's the situation we have right now. So if you can imagine taking the square root of 4yc, that's going to give you 2y, right? And the square root of 3 plus 1 is the square root of 4, which is going to be 2 as well. That 2 times that 2 will give you 4y. Okay, so this side SC is equals to 4y. You can then go in and substitute that. So we have d divided by 4y is equals to BC is also d, okay, divided by PS. We've already noted over here that PS is equals to QR, so we don't need to rewrite that reason. We can simply go into d minus 4y. Okay, then we can cross multiply over here because we have two fractions equal to each other, giving us d into d minus 4y. Okay, that is equals to d times 4y. We can then divide both sides by d, which will leave us with d minus 4y is equals to 4y, right? Adding both sides with 4y, we'll have d is equals to 8y, right? And since we need to write our area, okay, in terms of d, right, we need to then rewrite this in terms of y. Okay, so therefore y is equals to 1/8 of d. Okay, so this right here is now our constraint equation. Right, so our constraint equation is y is equals to 1/8 d. Okay, we can then take this constraint equation and substitute it right into our optimization equation, right? Okay, so substituting our constraint equation into the optimization equation, right, we can then write this as A, right, of D, okay, because now we're going to have the area of this rectangle, right, in terms of the variable D, right, this is going to be equals to 2 times the square root of 3, right, and in the place of Y, we're going to substitute 1/8 D. This is all going into, right, D minus 4 times Y is 1/8 D. Okay, so simplifying this, we'll have that 2 goes into itself once and into 8 4 times, so we have the root of 3 over 4D. Okay, this is going to be multiplied into, right, over here we have 4 goes into itself once, into 8 twice, so we have a half D, right, so we have D minus a half D, which is just 1/2 D. Simplifying further, right, we have that A of D, okay, is going to be equals to, well, now we're just multiplying two fractions, so we have the root of 3D times 1D is going to be the root of 3D squared, right, divided by 4 times 2 is going to be 8, right. Now we have our optimization equation in terms of one variable D, right. In order to find the maximum area, we would have to calculate A prime, okay, and then set that equal to 0, right. But in this case, you can see that our optimization equation is mapping a parabola, okay, and this parabola is a smiling parabola, right. So your smiling parabola is concave up, which means that it has a minimum. Okay, so it has a minimum turning point, right? So to answer this question, for the maximum area is just going to be given by your chosen D value. In this situation, we don't need to go into A prime, okay? Because A prime is not going to give us a maximum either way. The way that you are going to get your maximum area, right, is through the area of this rectangle in terms of D, right, for D greater than 0, right, because obviously D can't be equal to 0, okay, so your maximum area is just going to be determined by your chosen D value, okay, so therefore the maximum area of the rectangle, right, is given by chosen D value. Okay, and it might also be affected by other factors, like maybe let's say the budget that you guys have in order to construct this. So you would choose the D value that minimizes costs, right? Also maybe within the client specifications, right? So if you can imagine this, okay, this A of D formula, right, is mapping a parabola, okay? So if you choose a D value of 1, okay, so you make all your sides 1 unit long, right, so 1 meter, something like that, then the maximum area of your rectangle, right, is going to be the square root of 3 times 1 squared divided by 8, which is just simply root 3 by 8. Okay, if you choose your D value to be 2, right, then, okay, so this is the D axis and this is your A of D axis, right, then the maximum area of this rectangle is going to be the root of 3 times 2 squared, which is 4, right, divided by 8, which is going to simplify to root 3 by 2. Okay, and you can see it carries on. If you choose D to be 3, right, then the maximum area of your rectangle is going to be given by root 3 times 3 squared, which is 9, divided by 8. So you're going to have a maximum area of 9 root 3 by 8. Okay, so that's how you would go about solving this specific question. I'll see you guys next time.